Hey guys, these are the integrated science. We're in Unit 3, Matter, and we are on Skill 1, the last part, Part 5. Today we're going to talk about subatomic particles and how to calculate how many protons, neutrons, electrons, from all sorts of information. So there are two things you will definitely need before you start. First, handy dandy periodic table. Second, a calculator. All right, let's get started. So the first type of subatomic particle that I want to emphasize, and we've talked about this before, is the atomic number is the number of protons. And you can find that on your periodic table. Your periodic table is in an order of atomic number. So hydrogen is atomic number 1, so hydrogen atoms all have 1 proton. Okay, so whatever that 1, 2, 3, 4 number is, that's how many protons. And protons are in the nucleus, they have a positive charge. So let's do some practice problems. How many protons are in an atom of arsenic? So you find arsenic on the periodic table. It is over here, As, and you see that arsenic has 33 protons. What element has an atomic number of 5? Okay, so I go to the periodic table. 5 is boron. An atom has 40 protons. What is its atomic number? Well, number of protons and atomic number are the same thing. So it's got to have 40. All right. Let's move on to the next skill. So mass number equals the number of protons plus the number of neutrons. So this is saying how many things are in my nucleus. And the things in the nucleus, your nucleons, are your protons and neutrons. Those are your biggest subatomic particles. And I use quotes here because we're talking about really, really, really unbelievably small things. Out of your unbelievably small things, protons and neutrons are the biggest of the small things. So we don't count electrons here because electrons are so tiny, they don't even add to the mass of an atom. That's how incredibly small they are. So we're just counting up the total number of protons and neutrons. So an isotope of phosphorus has 17 neutrons. What's its mass number? First thing you want to do is find phosphorus on your periodic table. So you're looking for the letter P for phosphorus. And you'll see that phosphorus is atomic number 15. So you know that phosphorus has 15 neutrons. So since the mass number is protons plus neutrons, if protons are 15, so the protons part, and neutrons are 17, you add them up. 32 is the mass number for phosphorus with 17 neutrons. An isotope of bismuth has a mass of 210. How many neutrons are in this atom? Okay, again, find bismuth on your periodic table. So once you find bismuth down here in the corner, you see that bismuth has 83 protons, so you can put that in your head. So you use the formula. If the mass number is 210, and that equals the number of protons, which is 83 plus neutrons, so call that X. If you want X, or the number of neutrons by itself, you have to subtract 83 from both sides. So then 210 minus 83 is 127. Another way to think about it is you have 210 nucleons. 83 of those are protons, so the rest of them have to be neutrons. So you can quickly jump to the 210 minus 83. An atom has a mass number of 112 and contains 64 neutrons. What element is it? Okay, so again, you have mass of 112 equals number of protons we don't know, plus the neutrons, which is 64. You want to get X by itself, so you have to take away 64 on both sides. When you do 112 minus 64, you get 48. So you're going to follow your periodic table until you get to atomic number 48, and that's cadmium. All right, and then charge. So charge happens based on how many protons to electrons ratio. You can't change the number of protons in an atom, but if an atom gains or loses electrons, it's going to have a charge. And that makes it an ion. Anything with a charge, we'll get to that at some other time, but let's do some problems. An atom of calcium has a charge of 2 plus. Now you can have positive and negative charges, so make sure you track that in your math. How many electrons are present? All right, so charge is 2 equals the number of protons. Number of protons is the atomic number, so you go on your periodic table and find calcium. Calcium is atomic number 20. So 20 minus, we don't know the number of electrons, X. So 20 minus what gives us 2? The answer is 18. So this atom has 18 electrons. An atom has 33 protons and 36 electrons. What's the charge? Okay, the charge equals protons minus electrons. So 33 minus 36 equals -3. So 33, so this is an atom of arsenic, and it has a -3 charge. Which element would have a -1 charge with 10 electrons? Okay, -1 equals, we don't know the number of protons, minus electrons, 10. So we have to add 10 to both sides, and that gives us 9 protons. So this is an atom of fluorine. All right. And the last bit, we're going to add on a little more to the shorthand notation you learned previously. So before, you didn't have this charge up here because we hadn't talked about charge at all. So it's the same thing, mass number over atomic number, and then the symbol, but now in the top right, we're adding charge. So let's bring back our 3 other equations just so we have simple access to it, and let's answer a question. How many of each subatomic particles, protons, neutrons, electrons, are in this? All right, so let's start with protons. So this is Zn, which is zinc. So it's really easy to find the number of protons because you just find it on the periodic table. So the protons is equal to the atomic number, and that's 30. Okay, now let's find the neutrons. So when looking at this, to find the neutrons, the equation I want is that the mass number equals the number of protons plus the number of neutrons, which also means the mass number minus protons equals neutrons. So the mass is 67, because that's up top, minus 30. So the mass is the number of protons and neutrons. So if you take away the protons from it, you're left with just neutrons. So you have 37 neutrons. Okay, for the number of electrons, we're going to use the formula up here, because to figure out the number of electrons, you always look at the charge. So the charge is 2, and that equals the number of protons, which we know is 30, minus the number of electrons. So 30 minus what gives us 2? 28 electrons. All right, best of luck figuring out how many subatomic particles are in each isotope, and let me know if you have any questions, and I'll see you in the next set of notes.